Greetings, this is Two-Step Inequalities, and I got a question for you. What do you call a dinosaur with an extensive vocabulary? A thesaurus. Yeah, a thesaurus, get it? Anyways, uh, kind of a simple video. We're going to go through it with some speed here. I can solve two-step inequalities using the same strategies I use to solve equations with a few exceptions. So there's only going to be a few different rules that we apply to two-step inequalities that we wouldn't have applied to two-step equations. All right, here's some of those exceptions. When you multiply or divide by a negative number, emphasis on negative, okay? Has to be by a negative number, okay? The inequality sign has to be flipped. And just in case you haven't caught why that is, let me give you a little example. So I'm going to give you a true inequality. 6 is less than 12. Now we know that's true. 6 is definitely less than 12. But if I was to divide both numbers by -2, I would end up with -3 on the left and -6 on the right. And now it's a false inequality because this is saying that -6 is larger than -3, and we know that's false because if this was 0 on our number line, we've got -1, 2, 3, 4, 5, 6. -6 is a whole lot further away from 0 than -3 is. And the closer we are to the positive side of the number line, the bigger we are. So this has become a false inequality. Now, that means when we divide by the negative number, the way to fix this is to flip the inequality sign the other direction. Okay? But notice what would have happened if this was an equation. So if I got rid of the inequality sign and used an equal sign, 6 is equal to 12, from the very beginning we would have had a false statement. Okay? Because 6 does not equal 12. And just want to point that out. That's why we have to use an inequality sign here, is because otherwise it would be false to start with. But if you divide by a negative number or multiply by a negative number, flip the sign. That's the big message here. Okay? All right, so here's a first example. How to go about this? Well, you approach this just like any other equation, except it's an inequality. So you have to get rid of this 3, right? And then you got to get rid of the 5. So it's plus 3. So I'm going to be subtracting 3 from both sides. From both sides of this equation, I got to subtract 3. And so I end up with 5x is less than 15. But when I divide by 5, because 5 is positive, there's no need to flip the inequality sign. There's no need whatsoever. So I go, one step here, subtract the 3. Second step is to divide by 5 because it's the opposite. And I get x is less than 3. I'm not going to graph these solutions anymore because I know you guys know how to graph them. Just remember that when it's less than or greater than, we just use an open circle. But if there was, less than or equal to or greater than or equal to, we use the closed-in circle, if that was the case. So we'd use that for signs like this, and we use the open for signs like this. Okay, 2 more examples. This is, like I said, going to be a short video. We want to, in this case, we still got to get rid of the 2 before we get rid of this -2. So we got to get rid of this guy first here, this one I'm underlining in yellow. So I'm going to subtract 2 from both sides to do the opposite. And so I end up with x over -2 is less than or equal to 8, because 10 minus 2 is 8. Now this is where a lot of us, even with equations, struggled for some reason. Think about it like this. This is x divided by -2. We know the opposite of division is multiplication. So some of us in the past would have just multiplied both sides by 2. But you got to multiply by what, the exact same number to get it to cancel. So we really need to be multiplying by -2 on both sides. Now remember, what's the rule when we multiply both sides of an inequality by a negative number? We absolutely must flip the sign, okay? So that's our first step. These 2's cancel out. We're left with just x. X is now greater than or equal to -16 because 8 times -2 is -16. One more example, guys. All right. So in this particular case, it looks a little different because we have a -5 and a -3x here. So things look a little different. But we still approach it the same way. Got to get rid of this -5, so I'm going to add 5 to both sides of this inequality. These 5's go to 0 because -5 plus 5 is 0. But instead of just being left with 3x, I'm actually left with a -3x because this negative sign, stays. We didn't do anything to get it to go away. Is greater than 15. Now to get rid of this -3, we do the opposite because it's -3 times x. So we divide by negative 3. And so we immediately know, hey, we got to flip the sign. Okay, so we're left with x is less than negative 5. And that's our final answer. We would just graph it. All right. I think that's it. That's all there is to it, guys. It's just 2 steps, just like your equations. But keep in mind that rule about flipping the sign. Here's your number clue. This is for a new number. The last number, if you didn't figure it out, was, well, I'm not going to tell you what the last number was. You have to tell me what it was. But this is the beginning of a very, very new number. Okay, good luck, guys.